Hello, my name is Zoe Stokes,
And Morgan Bannister.
and we worked at Lubrizol doing a cycle count risk assessment analysis with our advisor, Linda.
So the first thing we're going to go over real quick is what exactly Lubrizol is. So Lubrizol was located in Bowling Green, so that's where we did our whole practicum. This company produces liquid soap, and one of the big things that they talked to us about was how they have to handle a bunch of different materials in order to produce their finished goods. So that's kind of what we went and looking at was what is the riskiest material when producing soap. So they had us complete a risk assessment in order to figure that out.
So, when we first started looking at the risk assessment piece, we thought that we wanted to look at the impact, the likelihood, and the frequency that could play into account. So, for impact, that means the lost money, production delays or stops, and some of the other things that are listed there. And then likelihood is volume, mistake for another material, inaccurate reporting, many of those things. And frequency is just the number of times that the material is touched. And we later ended up refining our equation to that top equation right there that says risk assessment equals impact plus frequency.
So the first thing that we wanted to do was get all of our data into one Excel sheet so we could look at it all together. So we put the packages in one, which was the single orders of material. So this is just like one material on its own, with the bulks, which was larger materials that later go into a tank. But we looked at it for the 2018 year, so we had a whole year's worth of data. And then the first thing we did was look at the number of discrepancies for each product. So they gave us a chart and talked about out of all of the times that it was counted, how many times there was a discrepancy. So we looked at the probability for each material. But then later we decided that we were going to change our point of view and not actually look at discrepancy, because it was later told to us that not all of the materials were counted every single time. So then it skewed our results. But we just thought that this was interesting, and we created a graph about the discrepancies so that later down the road, for more in depth about the project or even for a different project, that the managers could figure out and look at which products and materials had the highest discrepancies.
So our next step was compiling multiple categories that accounted for risk factor. So this was our impact. This is when we looked at the cost per pound of the materials. So we realized that some materials are going to be more risky or have more of an impact because they cost more. So the materials that cost $25 rather than $1 per pound are going to have more of an impact if they are found to have more discrepancies. And we also looked at the impact of the different types of goods they have. So they have raw materials, which is just the basic elements. And then they have their intermediate goods, which are the goods that are before the finished goods, so in the middle of being processed. And then as well as looking at those items in both the small packages and the larger bulk packages. And then through this, we also found the deviation for each type of good and packages and all of those materials. So this is an example of one of the graphs we had. So this is for the small individual packages for raw materials. Each material is listed by a different bar due to how the company's policies of the materials they have. We actually have to keep them private, all the different materials. So each material represents a bar on the graph, and you can see marked as the red, that is the highest costing material, versus over here on the right side, there are materials that do not cost as much. And using the deviations, we found different labels for materials. So there's 2 in this first red circle, and then there's 3 in this purple circle. And each of those got a number label that allowed it to be marked as more impactful, more risky.
The next category that we then looked at, which was frequency, and this was the number of touches, so the number of times that every material was touched. And we looked at this for both packages and bulk. However, in the last one for impact, we split them up between packages and bulk, and then we split them up again between raw materials, intermediate goods, and finished goods. But we decided that we couldn't do this because In some categories, materials were touched a lot, or in another category, they were touched a little, but then it kind of skewed the number of times because raw materials are usually touched more than finished goods. So it kind of changed everything there. So instead, we just compiled them into straight packages in straight bulk. And then based off the number of times they were touched in those categories, we then gave them a risk assessment, again, based on the standard deviation jumps. So we could group them based off of that.
So again, like at the beginning, we had our final equation to be our impact risk assessment and the frequency risk assessment to find our final risk factor. So doing so, we are able to account both of the variables we found most important when looking at the risk assessment. And each factor, the impact and the frequency, have numbers that go from 1 to 5, 5 being the most risky and 1 being not as risky. So if you look at our final results, these are just some of the materials. We were not able to put all of them in one graph because there are many materials. But 10 is the highest number that you could possibly receive, making it the most risky. That means that both the impact and the frequency were categorized as level 5. And then if you look, you can also see that the graph is color coordinated to which one had the higher values. But overall, the numbers on the left show that they had higher risk assessment factors and the ones on the right had lower.
So after doing this, we realized that there were many implications that you could use in a classroom. So the classroom activity that we have created is we would give the students the following activity. You're on a special task force to decide what cakes at the local bakery you should purchase for your event. However, occasionally the cakes are not made with the proper amount of ingredients, causing variation in the taste of the cakes. If the cake is not made with the correct amount of ingredients, it negatively impacts the taste. This is problematic because you are only given a certain budget to work with. Using the given information, which cakes do you believe should be made with your budget of $50? Explain your reasoning. So the students would be given a chart with the types of cakes, the price, and the probability. So using their prior knowledge, they would have to look at probability and figure out which cake is the most risky to make, or what is a chance of there being a discrepancy in the making of the cake. This will cause them to have to use analysis and their prior knowledge to figure out how many of each cake they should use, but they also have to kind of look at risk assessment to figure out if they should risk making the cake and return to losing the cost of how much they paid to make it.
For the assessment portion of the activity, we would have the students go ahead and give presentations in their groups, and this would be an example of a formative assessment. That way, as the teacher, we can see that they are meeting the standards. So the standards we have listed are from 7th grade math standards, and we believe that this is where you would most likely use this type of activity. However, it could also be used in an 8th grade classroom or even a high school classroom with statistics, because it still covers the same important information that 7th graders are learning.
So after being at Lubrizol for a whole semester, there were many things that we could take away about businesses. One of them is businesses have to do a lot of experimenting in order to get the outcome they want. Linda told us that they tried this multiple times, but they failed, so they had to keep doing it. Another is collaboration is key. She had to work a lot with the other business heads in order to figure out all the information that she needed for the experiment.
So for me, many things I saw were trial and error based. Not everything worked right away, and larger companies need effective communication. So like Morgan was talking about, the businesses have to talk amongst each other. And there's not always a clear solution. It's not always black and white. There's always going to be some gray area.
And then some benefits that could be useful in the classroom is professionalism and communicating effectively with others, like, again, talking to other people to get the information you need, how to effectively use Excel, and how to use statistics in a real world situation like we did in our activity.
For me, I saw benefits of, as an example of SMP4, so using real-world scenarios within the classroom. I was able to learn more about Excel, and I could communicate with other business professionals so that I could effectively learn communication.
Thank you.